Hey guys, welcome to Deep Neural. Vijay from this side. This channel is dedicated to explain deep learning and machine learning projects. Additionally, I will explain the concept which required to execute the projects that we are going to execute in future. So let's start with our first project, that is COVID-19 image classification. I found that data set, COVID-19 image data set uh, from Kaggle. Here you can see there are three folders: COVID, normal, and viral pneumonia. Basically, there are three classifications: COVID normal and viral pneumonia. And this problem is regarding image processing, so it is directly connected to the deep learning. They already splitted data into test and train folder, so we don't need to split our data into training and testing folder. It is already there. So let's go through the workflow. First step is image preparation. We will prepare image for the processing first. After that, image processing contains three steps. Will basically follow three steps. First is converting 3D image into 2D image, blurring the image, and resizing the image. After the image processing, it's time to train our model. The training of CNN model will happen with convolution 2D and max pooling. So these two steps may included in the CNN model. The model evaluation is based on several metrics like recall, precision, F1 score. These are the metrics, or you can use the mean squared error or root mean squared error. After evaluation, it's time to download the model. We'll download the model, and in this video we'll do first 5 steps: the image preparation, image processing, training, evaluation of model, and download of model. These two steps will take too much time, so it will be in the next video. Creating a package and package testing, these are the uh, different concept I will explain in the future videos. So let's start with the coding first. We need to create a new notebook here. Okay, this is Kaggle Notebook. In first cell, I imported all required libraries, NumPy, Pandas, and OS. In the second cell, I created some constants like root path. It contains path of this folder, first folder, that is the root folder. The main constant stores the path of COVID-19 dataset folder. After that, training and testing. For training and testing, I created two sections here: training and testing. And each section contains training folder as well as COVID, normal, and pneumonia folder of training section. And same structure is for testing. These constants will help you to segregate the path and to fetch out images from the path. So I created here two lists. Now I need to separate out the list, separate out training images and testing images. So that's why I created two lists here. This for loop is for training and this for loop is for testing. Basically, it is reading the images from COVID, normal, and pneumonia, and it is just appending these image paths actually into the list. After getting the list, it's time to separate out the list into different sections because we have three folders under the training. Our task is to classify in three categories, so we need to separate out these paths into three sections, that is normal, COVID, and pneumonia. For that, this for loop is for training and this is for the testing. It just separate out the image paths into normal, COVID, and pneumonia. If suppose normal is present in the path, then we need to append the path to the training dict of normal. The normal is the key here, and this list is a value. In this list, we are appending this path. For the same for the viral and COVID. So we will get a dictionary here for the training and testing. So let's start image processing now. I imported CV2 and matplotlib here. The created two dictionaries, train IMGs and test IMGs. This for loop I iterated through training dict that we already created here. Training dict contains three keys and three values. So there are two for loops. First for loop finds for the key, and the second for loop is fetching the path through that key value. Hmm. The first line, that is cv.im read, that reads the data from the path and convert it into the array format. Then second line, it converts the 3D image into 2D image, or you can say BGR to grayscale image. In third line, we blurred the image. After that, we resized it, and at the same time we normalized it. Then we reshaped it with the shape of 32 by 32 by 1. It is important because CNN takes the format like this: 32 by 32 by 1. The shape, the CNN requires this kind of shape, and appended temp list, and the same temp list then updated with train imgs dictionary. So first for loop works for the training, and second for loop is same and it works for testing. This is processed image, it looks like this, and this is unprocessed image. So you can see here, we reshaped it 32 by 32, so it is 32 pixels, sorry, 32 rows and 32 columns. And this image has about 1600 columns and 1400 rows, so it's too much for the processing. We don't have that much processing power, and we can't work with it. It will take too much time to train a model. It will take hours and hours to train simple model. So now we will proceed with the training of model. For that, TensorFlow, I imported TensorFlow and keras from TensorFlow. So before training, I converted our data, or I splitted our data into training and testing. Here y train, y test, x train, x test. Then I converted this lists into tensors. This is important while training our model because we are using the CNN from TensorFlow. So the TensorFlow supports tensors only. It will create a model with the NumPy array as well, but it might get an issue in future while you are working with the same code, while you are updating that. That's why you need to follow standards. So this is the model that I created here, the keras dot sequential. In this, the first step is convolution. This 32 indicates that 32 features are going to create, 32 features will create, and 3 by 3, this is the kernel size. Activation, we used ReLU, and input shape is 32 by 32 by 1. Yeah, here is the input shape. I already mentioned before, I already reshaped it 32 by 32 by 1. So you may got it for why I reshaped that. This model requires 32 by 32 by 1. So here the next step is pooling. I used a max pooling. There are several pooling techniques: max pooling, average pooling, then sum pooling. So most of the cases we are using max pooling to fetch maximum information or highlighted information from the image, and its size is 2 by 2. The same convolution we used two times. After that, we flatten the array. Flattening array means it converts 2D or 3D array in one dimension. Now we used three dense layers here. First dense layer, which uses activation as a ReLU. Second one is the same, and third one uses softmax. We are classifying in three categories, so it is mandatory to mention or to write here three. Unit should be three. So after that, it's time for compilation. For compilation, optimizer is Adam, loss is sparse categorical cross entropy. We are classifying in three different categories, so the loss should be sparse categorical cross entropy. For binary classification, you should use the binary cross entropy, and the matrix is accuracy. We used only one matrix here. Model.fit will train the model with x train and y train, and epochs are 10. Here epochs means the iterations. We used 10 epochs, that means 10 times our neural network will get updated with the same data, and at every iteration it will update the weights of each neuron. So if you are using much epochs, if you are using 10, sorry, 100, 200 epochs, it will show you higher accuracy, but it evaluates on training data, so it may get overfitted. So to avoid that issue, you need to do trial. You need to do several trials before before deciding how much epochs I should use. It's a trial and error process. So this is the model summary. The I evaluated model with the testing dataset, and it gives me 89% accuracy. Here are the predicted values. Y prediction. The evaluation I did with the classification report. Here you can see precision, recall, F1 score, and support. 0, 1, 2 are the classifications. These are the classifications. For 0, precision is 1, recall is 0.96, and F1 score is 0.98. For 1, precision is 1, recall is zero point 0.7, and F1 score is 0.82. For 2, same thing. So it's time for the confusion matrix now. Yeah, I plotted here confusion matrix. Okay, this is the confusion matrix. Here you can see the predicted axis, and this is the true axis. Predicted axis shows you the predicted outputs, and true is for the actual outputs. This confusion matrix show us the how much time our model misclassified something. So here you can see 0 one time our model predicted 0 as a 2. So 6 time the value is 1, but our model predicted it as a 2. So these 6 and 1 are the misclassifications. As compared to these diagonal values, these misclassified values are too less. So we can say that our model is performing better. You can see here, after that we created model, we evaluated it. Now it's time for the download. You can download the model with joblib, or you can use the TensorFlow model library to download the model. Go to the output here and just download it. Yeah, it downloaded the model. So this is enough for the day, guys. We just downloaded the model. Here we performed all 5 steps: image preparation, image processing, then we trained the model, evaluated it with precision, recall, F1 score, and downloaded it. So our first 5 steps are completed. In the next video we will create a package, and we will test a package as well.